we recognize coupling's important in large code bases. Too much coupling causes problems, but a lot of times when developers are interacting with each other, the term coupling is thrown about fairly loosely. Where on the same piece of code, the exact same section of code, one developer can say, that's good, I like it, it's loosely coupled, and another developer can say, what are you talking about? It's awful, it's a tightly coupled mess. And part of the issue is that it's very subjective, and we take the term coupling to mean either I like it or I don't like it, which unfortunately there's no accounting for taste. But for us, in the context of this class, we're going to use a definition of coupling that says coupling is a measurement of dependencies. So if there is a dependency, if X depends on Y, there's coupling between them. The important distinction is that there's actually two different types of coupling. You can think of it as the coupling from the perspective of X and the coupling from the perspective of Y, and each of them has its own name. So when we're talking about afferent coupling, that's the coupling from the perspective of Y in that example, who depends on me? The incoming coupling, all right? Whereas efferent coupling is that what are the things that I depend on, the outgoing coupling, all right? So don't worry too much about the names afferent and efferent. Just think of them incoming and outgoing coupling. Whoever named those things used words that sounded too similar to each other to be used in common everyday language. So incoming and outgoing is what we're going to be calling them. So if we say that X depends on Y, that means that there is outgoing coupling, efferent, from X to Y, and there is incoming coupling into Y from X, all right? Now that we recognize that we have two different types of coupling, when we look at a piece of code and say that's too tightly coupled, we need to be more specific. What kind of coupling and how much of there is it? So looking at a bunch of pieces of code, and right now think of them just as classes, all right? So nothing distributed at all. Everything running in the same process. We've got class A, B, C, and D, all right? Where we have the incoming coupling of each of those classes. So how many other classes depend on A, B, C, or D? And we have the outgoing coupling. How many other classes do they depend on? All right? Now, before we get into which of these is worst, let's talk about which of these is best. Which of these is most loosely coupled? Yell it out for me. D, right? D is great in the sense that nothing depends on D, and D doesn't depend on anything else, right? Is that good or bad?
That's useless.
It might very well be useless, right? It's kind of like an appendix in a human being that at some point in time in evolution, maybe it served a purpose. But since then, we kind of refactored around it, and nobody wanted to delete it, so it's just sort of there.
It can still infect and cause you to crash.
And it can still cause problems in the form of infections. So in terms of D, we're saying it's so loosely coupled that it might be useless. It would be better to be deleted rather than to leave it in there. Because unlike a human appendix, there's actually no cost to removing it, right? No risk in terms of surgery here. So great. So D is so loosely coupled that we actually don't want any code that looks like it. So what was considered best in terms of loose coupling, we recognize is probably worst. Okay, good. That's kind of the point of this class. Take the thing that you're sure that you're right about, and then turn that right back around at you. A, B, and C. Which of them is better than the others? So who likes A more? All right. Some hands going up. I got 3, 4, 5, 6, 7, 8. All right. Who says B is better? Who likes B more? I go 1, 2, 3, 4, 5, 5. Who likes C better? Because 2 plus 2 is clearly less than 0 plus 5. 1, 2, 3, 4, 4. Who says it depends? Oh, I didn't know that was an option. All the consultants say, it depends, obviously. Just as a note for those of you either present day or past day or future consultants, if you want to answer a question with "it depends," you must provide a fully formed "it depends" answer, kind of like fully formed estimates. A fully formed "it depends" answer is, it depends, comma, if A, then this option is better. If B, then that option is better. In other words, you must provide the justification under which condition each of the options is preferable. If you just say, well, it depends, you have said nothing. All right? So for all those of you who raised your hand and said, it depends, who would like to give me a more fully formed it depends answer? Udi, are you joking? After lunch? Coffee hasn't kicked in yet. So for those of you who said A, somebody raised their hand for A? All right, why A? What did you like about A?
High fan in, low fan out. So typically a class itself should have not a lot outgoing dependencies.
Okay.
But it's okay for him to be dependent upon.
Okay. So saying that the fact that it doesn't depend on anything else makes it fairly self-contained. And that's generally speaking a good thing in software. And the fact that it's used in a number of places is also an indication that it's a useful class. So it's a self-contained useful class. That's something to like, absolutely. How about B? Anybody want to say what they like about B? Yeah.
Well, since it doesn't have any dependencies on it, then
Right.
meddling with it won't fuck up anything.
All right. I'm not going to repeat that exactly. But in essence, what we're saying is B is safe to change, right? If I make a change to B, I don't have to worry about breaking other pieces of code because nothing depends directly on it. Whereas with A, if I make a change to A, I might potentially break a number of other classes. So the fact that B is using a number of other classes, that's reasonable, right? Classes do call other classes. That's fine. So what about C? Is C not the worst of both worlds? Anybody want to argue for it being the best of both worlds?
Sounds like integration to me.
Sounds like integration. Integration's a nice big word. What do you mean by integration?
Well, integration is when you take something from somewhere and present it to somewhere else, isn't it?
Okay.
Well, usually it will depend on stuff, and other stuff will depend on it.
All right. So,
I'm thinking that's a big ball of mud to say.
well, it might not be a big ball of mud. It might be a small ball of mud, right?
This would be a typical command handler.
This would be a typical command handler. So maybe let's use the more generic term service layer, where it is called by a certain number of things, and it in turn calls a number of other classes. So for example, the things that might be calling are domain entities, right? And clients might be things that are invoking the service layer. So business logic, service layer type code often tends to have something that looks like this in terms of its coupling signature. And that's expected, right? If we saw a piece of business logic that nobody called, right, if it had a 0 like B, I'd say, that's kind of weird. Why would you have business logic that nobody's calling, right? But let's talk a little bit, well, what kind of code? We said service layer, integration, business logic-y type code fits into this category. What about B? Can you give me an example of a type of layer, for lack of a better term, that would look like B? Presentation layer. So user interfacey type code closer to the top, where in essence the user via some sort of user interface is interacting with it, which gives us button clicks or whatnot that call into this class. In essence, this class gets called back by registering for a button click handler or something like that. And it in turn calls various other, let's call them controllers or service layer-y type things to say button click equals invoke this, do that type of functionality. All right, good. What about A? Give me an example for a class or responsibility that looks like a
Library code.
library code. Can you be a little bit more specific? Because
Serialization code for the
framework,
framework.
serialization, logging. All right, that's a better, more specific example. Logging.
Date utility, whatever.
The utility type, so low-level type of functionality where, again, we expect it to be fairly self-contained, right? That's the important distinction. And we'd expect it to be used in a number of places. Now, this is the point where I want to reframe the coupling discussion to say, what if it was used in 50 places and not 5? Let's use logging, for example, all right? If you looked at the coupling signature of a given piece of logging code and you saw that this was 50, would you be concerned? Yes? No?
Yes.
Yes. Why?
Well, logging is a great example, and I think you already addressed this a bit. But if you see logging throughout your application in almost every class in your application, what we see a lot, you're doing things wrong.
Okay, so you're saying that if logging is used everywhere, you're doing something wrong. Can you explain why that's wrong?
Yeah, because typically we want to have logging placed on certain boundaries in the application. For instance, my neighbor here in front already talked about the command handlers a bit. If you have the right abstraction in place in the system, you can place almost any business logic, wrap it with, for instance, a decorator. Then you have that logging in just one or a few spots in your application.
Okay.
And well, 50, well, it's perhaps a bit arbitrary, depending on the size of your system. But I see it a lot where logging is injected into almost any business class.
Right.
Whereas we log everywhere and everything, and that's almost always a bad thing.
Right. So if I reinterpret your statement saying that the better approach is to have some sort of generic interception behavior so that we don't need to remember to log everywhere. So in other words, by creating some type of, again, whether it's injecting it into the HTTP pipeline or the queue processing pipeline or anywhere like that, then logging will happen for all invocations that are coming through it without developers having to remember to write the logging code everywhere.
Yeah, and not only remembering, but also testing it. Because if you write to the log from a class, you want to test it, unit test it.
Right. So from the testability side of things, again, I don't think that we're concerned about the coupling elements per se. We're concerned about other attributes of the code base rather than the fact that it's used in that many places, right? We want the logging to happen in that many places, and we want other things from our code base, for example, that element of being able to unit test our code effectively and make sure that, well, if the logging responsibility, as you said, is in the class itself, then we need to assert that the logging is actually functioning correctly, and then we'd have to test that for every single bit of code where it's being used, as opposed to testing it in one central location. However, one of the things that you didn't say is that that creates a coupling problem, right? You described a whole bunch of other problems related to testability, and they're valid. But we wouldn't necessarily say that that's what makes our system unmaintainable necessarily in sort of the large sense because of the coupling. Now, that's the important distinction that I want to call between incoming coupling, we're saying, you know, I'm logging all over the place, versus outgoing coupling. So if there was, let's look at B here for a second. If this wasn't a 5, but if it was 50, can you give me a scenario where something like that would still be reasonable?
As long as you're coding to interfaces, you're just dependent on things below you. You can change those things and enhance them. It's fine as long as you're adhering to the same interfaces.
Right.
As long as you haven't got dependencies going up, it's always down.
Right.
It should be okay.
Okay, so you're saying that as long as our outgoing coupling is coupling to an interface rather than to a concrete class, then the amount of coupling is less significant. So first of all, allow me to challenge that, all right? Unfortunately, in most statically typed languages, we don't have the ability to have full design by contract via our interfaces. So there are certain things that we can assume about an implementer of an interface, but my guess is that a lot of you have experienced that element of having some other class implement that interface that still causes your code to break. Has that ever happened to you? You sort of plug in another implementation, caused it to break? Yes. So that's that whole idea of, oh, then we should just be able to swap out the database, a third-party service, a calculation function, and finding out much later that actually it's not really that simple. Why? Because the interface does not capture enough assumptions about the underlying behavior. Now, that'll be challenge number one. Challenge number two, if you're really taking a dependency on 50 interfaces, all right? So even if we grant that interfaces are the better way to take a dependency, isn't there some number where you say that that's too much?
Sounds like a horribly huge class with which does 1,000 different things.
Sounds like a single responsibility principle violation.
Right. So as this coupling starts to increase, it's hard to believe that the class really fulfills a single responsibility. If it needs 50 other dependencies in order to do something, it kind of makes you wonder, well, what on earth is it doing? Why does it need these 50 other things? And that's usually when we say that a given class or a given piece of code is tightly coupled, usually we're referring to this type of outgoing coupling more so than the incoming coupling. So while we look at a logging library or an ORM framework or a dependency injection framework or any of those types of things, and we're perfectly happy having a large amount of incoming coupling on those libraries, when it comes to the outgoing coupling, we're usually less thrilled about that. One of the reasons is that when we take a dependency on low-level library code, it's usually very generic in the sense that, oh, this is logging. This is not logging for insurance. This is not logging for retail. This is not logging for healthcare. It's just logging. It's the same logging regardless of the domain that you're operating in. Whereas when we're talking about outgoing coupling, a lot of times that outgoing coupling is to domain-specific things. And while it's very likely that generic library frameworky type code can be stable, the more domain-specific dependencies that we take are usually much less stable. So that's the second attribute that we look at when evaluating how coupled a code base is are we coupled to stable things or are we coupled to volatile things? So if we take dependencies on logging all over the place, that's much worse, that's not nearly as bad as taking a dependency on, say, a given calculation function in our domain. Because we know that that calculation is going to change more frequently than the logging behavior. Now, the thing that complicates this sometimes is, well, how do you count the coupling? I mean, it gives us an idea of how do we quantify things to have a number. But when we have two pairs of classes, where let's say X is only using one method of Y, but A is using multiple methods and a couple of properties of B, we can sort of, in our gut, sense that there should be more coupling represented here than there is over there. The only question is how to represent that. The way that I recommend this, and it depends on the static analysis tool that you're using in order to calculate these numbers, is that I'd say that the outgoing coupling of A is larger. It's 5 in this case, whereas the outgoing coupling of X is 1. But the incoming coupling of B and Y are the same. It's both 1. The reason being, when we're looking at incoming coupling, our concern is, if I make a change to this class, how many other classes might I break? And the answer, both for B and Y, is the same. It's 1. When I'm looking at the outgoing coupling, which is the conversation that we had over here, one of the questions that I'm asking is this class fulfilling the single responsibility principle? And one of the things that we can say is that the more outgoing calls that it makes, regardless if it's to one other class or to 2 or to 5, that influences how self-contained it is. So the more things that I call out to, that should be represented as an element of outgoing coupling. So when you're thinking about, well, what number? Is 5 okay? Is 10 okay? The exact number that you cut off things at is less important, but that you go through this process of deciding, how do we count coupling? And then the next step is going back to your team and saying, we should measure this stuff. Now, why is it important to measure this stuff? Remember what I told you about projects. Most projects, most code bases, start out fairly well designed, but they gradually get worse and worse over time. It's helpful to have some sort of metrics in place to be able to yell when, oh, this bit of code exceeded some threshold. If you say 50 is too much, you can create a certain rule in your build server to say, if the incoming or outgoing or both coupling is larger than a certain value, fail the build. And you can, if you want, you can have that be more layer specific. So for example, you can say, if this is code in the presentation layer, and you can evaluate that based on a naming convention of it ending with controller, for example, the incoming coupling should be 0. If a developer creates a bit of presentation layer code that doesn't have a 0, say, maybe not fail the build, but this starts to become dependent on what you agree on with your team. Say, you know what, we're going to fail the build, but if you can get another developer to look at that and sign off on it, then that's fine, just let it in. And I've seen this trick work incredibly well on teams across the world. See, the average developer, when they're faced with a choice of clean up my code to follow the rules, or talk to another developer and explain to them why I'm allowed to break the rules in this case. Talk to a computer, talk to a person. I'm going to talk to the computer. I'll just quickly fix up my code to follow the design guidelines and just run straight ahead. And under those few rare conditions where the developer says, no, specifically in this case, it must be different, then great, they'll have a conversation with somebody else, and more of that knowledge will percolate across the team. Why is that important? In 2 forms. A, it keeps the code following our hopefully agreed upon design principles in the team, and that when we divert from those principles, we communicate more broadly about it. And those are the kinds of things that help keep code bases more well-designed in the long term. And when we end up diverting from it, that there is more knowledge as to why we did that and it gets challenged. I'd say that's why it's important to measure this stuff. So that you can say, library type code should look like this. There's another category of code that also looks very similar to this, and that's DTOs, data transfer objects. Data transfer objects should be largely self-contained. They really shouldn't be referencing a bunch of other stuff. And they're often used in a reasonable number of places. Say, if it's a DTO, and I see that you're taking a reference on something else, maybe we should either fail the build or have you fix that up, or talk to another developer and explain why you did that. And your presentation layer should look something like this. And if in your presentation layer this number is greater than 15, we're going to fail the build. Now, again, don't just inflict these rules on top of your developers. Have a conversation as to why something makes sense for presentation layers, why something makes sense for DTOs, what's the value in adhering to those patterns across the code base. And always giving people an out, saying, but if you feel that that's too restrictive for your specific case, get another developer to sign off on that. And I guarantee you, 9 times out of 10, developers will clean up their code, which is really what we want. All right? Now, there are certain things when looking at C business logic, we should say, if this was 50 and that's okay, and that's 50 and that was bad, this definitely shouldn't be 50 or 20 or something like that. This outgoing coupling is really what kills us. But C can actually be the worst of both worlds because C can be largely unstable because of the outgoing dependencies. The concern is that it can destabilize other things. So if we're okay with larger numbers over here of, let's say, 5 and 10 and 5 and 10 here, we should be not as willing to have 5 and 5 or, heaven forbid, 10 and 10 over here. All right? That's really a recipe for a disaster. So when you have this type of core business logic, you really want to keep it scoped down as much as possible.